Right, so we want to be able to use it safely. So the main dangers are fire and fumes. Okay, so if we're using the wrong settings, or if you've got the wrong materials in there, we could set something alight potentially. Or if we put some materials in there, they could be potentially dangerous in terms of the toxicity of the fumes and things that could be generated. Some of them as well can actually damage the machine because the fumes that come off the materials are corrosive, and that can eat the coatings off the lenses and the mirrors, and actually just damage, basically corrode the machine inside. So it's really important that we know what the material is. Okay, so the rule of thumb is, if you don't know what the material is, don't put it in the machine. And if you don't know that material is safe to cut, don't put it in the machine either. It's quite easy to Google materials and what other people have done and whether or not it's safe to cut it. And just because a piece of plastic, looks like acrylic, doesn't necessarily mean that it is acrylic. And so when you buy in your materials, it's a good idea to keep them in the original packaging, or at least have some sort of system where you know what they are. Otherwise you can start mixing materials up and then you don't know which sheet is which. Okay, so fairly sort of basic workings of the machine then is there's a laser tube in the back here where the laser is generated, and the beam comes out of the laser tube and hits a mirror on this corner. Okay, so that turns the beam to face forwards. And there's another mirror on the end of this gantry and this carriage. Okay, and that turns the beam sideways to come in this direction. And then on the head inside the machine, there's another mirror, and this turns the beam again through 90 degrees, so it's actually going vertically down. Okay. And then passes through a lens, and then onto the material. Okay. So that lens has a focal length, so it's really important that we focus the beam onto the surface of the material. Okay. That's what this little probe here is for. So if I put a piece of material in there, we can actually raise the bed up and down until this is focused on the surface. Okay. The fumes are extracted. So if we go through just cover the basics first. Yeah. So the beam then processes the material. We're either going to cut it or we're going to engrave it. That generates fumes because we're actually burning through the material. That's dealt with an extraction system. Okay. So there's a big pipe that comes out of the back of the laser. So this is sucking air in through the front, and then the fumes out of the back and into this unit. That unit has a 2-stage filter. It's got a big corrugated cardboard paper filter basically that takes all the particles out of the air. And then underneath it's got a charcoal particle filter as well that deals with all the fumes, smells, etc. Okay, so to switch it on, and there's a switch on the side. So just switch it on. The first thing it'll do is actually park the head in the corner. Okay, so it'll move the carriage all the way back, moves the head to this side first, and then back to the left-hand side. So that's now honed itself, and it's in the 0 position. It knows where the carriage is, etc. So the next thing we'd want to do is focus on the material. You don't have to put the material in the corner. Obviously it's a good guide to the position of the material. It just depends what you're doing. There's 2 ways of locating things really. You can either put them in the corner, or you can put them anywhere you like, and you can manually move the carriage over to have it start in a particular location on the piece of material. That's a really useful thing to be able to do if you've got an offcut where it's already been used in lots of places, but there's a good piece maybe in the middle, so now we can actually move to the middle and get it to start at that location where we know we've got good material. So to focus it then, this little probe needs to sort of be at the surface. Okay, so we need to be able to move the table up and down. So to move the table up and down, first have to press this button, and that's put it into a focus mode. Okay, so now we can actually move the table up and down with these two buttons here. Okay, so yeah, so those two buttons there. So obviously that's too low, it needs to come up. Okay? It's quite hard to tell though when you come up whether I've actually contacted it. But if it's too high in the first place, then it's quite easy to tell now when it gets into focus, because I can actually visibly see when that comes into a vertical position. So that's at the surface. You need to actually park this back in that position as well. So depending on where the material is, you can slide this backwards and forwards. If we happen to want to focus on a piece of material that wasn't in the corner, then we would need to be able to move this carriage forward. You can move it when the machine's off. And the other way you can move it is to unlock the XY stepper motors. Yeah. So once XY is disabled, actually pull this forward. Then you could actually focus anywhere you like then within the bed. So I'll back that back. And then if I say, if I hit the return on there, and then it tries the exit again and park it back in the corner. And every time it parks in the corner, it comes to this side first and then goes back to that side. Okay. So when we cut things out then, especially small things like this, you get lots of small debris. It does have a grid table, cutting table underneath, and that allows the laser to pass through the material. It's really good for extraction of fumes as well, because it's actually sucking down through the table and out through the back. Okay, so there's a cavity underneath there. Small offcuts, waste material can collect inside that cavity. Okay, that could be a fire hazard. So to deal with that, we need to be able to lift this box out of the machine. It's quite tricky. But once we've then got it out of the machine, we can undo these screws. Take this cover off. And then empty that box into the bin. So it's important to keep an eye on that so we don't have an accumulation of debris then. Actually you can see there are 3 holes at the back here with a rubber or foam gasket. So this is where the air has been sucked out through this box, through those 3 holes in the back there into the extractor. Okay. Let's get this back in. Actually, before I put it in, I'll show you the pins. So the box has these pegs on the bottom, and the rulers inside the machine has these slots that the pegs fit into. So that's how we know it's in the right place. And the trouble is that when we put the box in the machine, we can't actually see the pegs or the holes. So now it's quite hard to know whether this is in the right place. Obviously, if it's in the wrong place, when we put our material in the corner, the position of the job in the machine isn't going to correspond to where it is in the computer. So to actually get it back in the right place, the easiest thing to do is to switch on the red beam pointer. Okay, so there's the actual laser that does the cutting, which is invisible, you can't see it, but it also has a second laser just for positioning. So we can actually switch that on by pressing this button. Okay. So So that's the same kind of lasers you might find in the laser level or for a presentation pointer or something like that. So just the same as with those things, you know, you don't look into it, okay, so but it's not going to cut your fingers off or anything like that when you put your finger underneath. So with the red beam pointer on there, you can actually see now where the core of this should be, and that makes it much easier to get the pegs into position. Okay. I'll switch the red beam pointer off, and in order to be able to move this thing, I'm going to disable the XY again, and we'll have a take a look at the lenses and the mirrors. So when we're processing materials, we're generating fumes, you know, especially on things like wood and MDF. Those fumes and resins and things can actually accumulate on the surfaces of the mirrors and the lens and make them dirty, basically. So every now and then, we're going to need to clean these. So on this machine, I found the easy thing to do is actually unscrew this mirror. And the surface of it, it's obviously only done 2 key rings so far, nice and clean. Yeah? If it was dirty though, you would use basically a lens cleaner and lens cleaning tissues. Yeah? So this is what's coming with the machine: lens cleaning tissues and lens cleaner. Okay, so you would actually tear the piece of this off, same as you clean your camera lens or something like that.
Yeah. Hi.
Yeah.
Hi. Oes rwy'n, da ni'n symud I mewn i'r area a da ni eisiau cael gwybod dim bach o information about maybe grants or stuff like that. Who do we need to speak to?
Ella'r tîm dros
Nesa.
Os dyn nhw'n yma
Iawn,
heddiw,
ocê.
gofyn am Mel ella.
Yeah.
Okay, so these filter papers, then we would just tear a piece of this off, even though it's clean. I'll just show you how to do that. So with a piece of that torn off, you put just a tiny bit of lens cleaner on there. What you don't want to do is any sort of mechanical scrubbing, because you'll damage the coating on the actual mirror itself, and they are quite expensive. So we want to be sort of fairly gentle with it, and clean it fairly often. What's the key really?
How often, then?
I think it depends on how much it's been used and what it's been doing last, you know. I think if I didn't know when it was used last, I would definitely check it, yeah. Or if I knew that somebody had been cutting some plywood with it, I would check it as well, because that genuinely can make it dirty. But I think I'd look at it at least once a week in any case, just to make sure they're clean. What can happen is, as they get dirty, some of the laser energy is absorbed then by that debris on the surface of the mirror, especially the lens, and that can have the effect of heating up the lens. Yeah? So I've actually seen lenses crack when they're really dirty because the laser's basically cooking the lens itself. There's another, so that was the mirror. There's a lens underneath here as well. The manual doesn't tell you to take this off to clean it, but you can't even see it, so you're not going to even know if it's dirty or if it's clean once you've finished. So that's the lens. That's got about a 2-inch focal length, you know, which is the height set by that lever there. And what can happen with this then, because this is at the business end of doing the cutting and the burning, is that you can get debris accumulating on the surface of that lens. Yeah? So we definitely want to keep that clean. So you'd clean that in exactly the same way. Try not to touch it with your fingers. Yeah? So yeah, like I said, not the easiest thing to get back in there either. There's a procedure in the manual actually for cleaning it. They don't tell you to take it out. So I'm not sure how you're supposed to know if it's clean or not if you can't see it. I suppose one way to do that would be to get a mirror and put a mirror on the bed so that you're actually looking up into the lens. And then if you had something like a cotton swab, like really high quality ones, you might be able to then clean it without having to take the lens away. Yeah. Okay, so you need to make sure they're clean. there are other two mirrors in there, like I said earlier, so potentially they could get dirty as well. But you know, nowhere near as often as these. But definitely worth sometimes having a look at them. You would need to make sure it's unplugged and everything. Take this cover off so that you can have a look at those lenses. Yeah. But generally, you know, if this is clean, they're definitely going to be clean because they're at the they're further away from the actual cutting. But I think, you know, every few months I'd probably have a look at those. But like I say, unplug it first. Okay, so now, you know, it's just convenient to be able to move this around just so that you can actually get to the lens to clean it. But I'm going to return this again because we're just going to press the back button, top the target in the corner. So if we keep it clean inside and we don't have an accumulation of debris inside, yeah. If we focused it properly, you know, if we know that the materials are safe and we know what the materials are, you know, the other things that we need to do is we need to use the correct power settings and we need to use the correct speed settings for that material. But you know, the number one rule, the most important thing, is that you never leave it unattended. Okay. Because you know, the fires can start inside the laser, and if you're watching it, then you can actually nip that in the bud. You can pause the machine. You know, hopefully the flame will go out once you've paused the machine. If it doesn't, there is a CO2 fire extinguisher over here. You can actually use that to put a fire out. It's quite normal to have a small flame on some materials under some circumstances, which would actually just follow the laser, so it would immediately extinguish as the laser's travelling along the material. If it doesn't, and if it starts to linger after the laser's gone and the material's caught fire, hasn't it? Actually, just switching the machine off, you know, will quite often actually just, it'll go out by itself. Okay. If it doesn't, like I say, you know, open the lid and there's a fire extinguisher there to put it out. But if you're not standing here watching it, then you can't nip things in the bud. You know, it only takes a few minutes. By the time you come back, there's a big fire inside the machine. Okay, so that's the number one rule. The two main things really is make sure you're watching it and make sure that the material's safe. Okay, so the machine is ready. Okay, so we focus that onto the surface of this material, haven't we? So we know it's clean inside, yeah? The other thing we do have is two things actually, extraction and the compressor. So the compressor at the moment is here. But you can actually hear now that this is blowing air. Okay, and I can actually feel it there. So it's blowing a stream of air past the lens, which it helps to keep the lens clean, but it's also helping to clear the combustion fumes and things away from the cutting area. Okay, so it actually helps it to cut as well. So it's important that that's on. Second thing is the extractor. So the switch for the extractor is on the back. There's a toggle switch on the back. It's only got one control really. That's the speed of the fan. Okay, which is just, you know, it's basically how much volume of air we're trying to move through the extractor. It also has a pressure sensor inside, so we can detect whether the filter's blocked. Okay. So if there's a big suction inside, it means, you know, the filter's partially or completely blocked. This can sometimes sort of give you a sort of a warning, just because somebody's cranked this up too high. These were partially blocked filter. with this cranked up all the way to the top. Could give you an alarm. Doesn't necessarily mean that the filter's unusable. Okay, all it means is that we're trying to shift way to more air through than we need to. Okay. So what you could try, if you have an alarm, is just have a look to see how fast it's going. And about half these blue lights letting up. You might find that the alarm goes out if this is not too high, okay? So it's really hard to tell, is it blocked? And when do we need to change the filter? So, a good visual way to check is, can you see smoke accumulating inside the machine? If smoke is building up in the machine, we need to possibly crank this up a bit to get this to go faster. If that results in an alarm on here, then we need to change the filter. Okay. But just because it's alarming, if this is all the way to the top, it doesn't necessarily mean it's blocked. You might still have a couple of months of life left in the filter. They're about £200 each, okay, so you don't want to change them until you have to. So the best way to check is to look in the machine, and also if you can smell smells in the air, there's obviously a problem with the filter. Okay. But that you have to manually switch this on. It doesn't come on automatically with the machine. So that's quite easy to forget to put it on and start a job, fill the thing with smoke, and then so just if that happens, don't open the door. Just switch the extractor on. Okay. Right. So. Here's a good example, really. Things that you can do with a laser then is, one of them's engrave things, and the other one is cut things. Okay, and there's an example of both on that key fob, yeah. So for engraving, what it's looking at really is pixels, okay, areas of colour, and it's going to scan over that area of colour line by line, so the laser's travelling backwards and forwards, left to right, over the area, line by line, okay? So how many lines there'll be will be dictated by how many dots per inch we tell it to use, okay? So that's called raster engraving. The other thing it can do is vector cutting. Okay, so we're following vector lines. Okay, so these are no longer pixels, it's a line that has a start and an end and a direction, and the laser will follow those lines. And the two parameters that we can change, the main parameters, is how much power we're going to use and how fast we're going. Okay, so the slower we go, the deeper it's going to cut, or the deeper it's going to engrave. Or the more power we use, the deeper it's going to engrave, or the thicker material that we can cut with the machine. So those are basically the two different things that you can change. And there is a third parameter, and it's dependent on whether you're engraving or cutting. It's basically the frequency of the laser. So how many laser pulses it's generated, per inch or in hertz, per second. So they have the effect of, if you imagine if the laser's travelling along and it's shooting out pulses, a higher density, higher frequency of pulses, we have a slight overlap to the pulses, okay? And that has the effect of putting more energy into the material and heating up the material more. When we're doing things like acrylics, that's beneficial because we then get a sort of flame polished edge to the acrylic. Okay? But sometimes you don't want to put too much heat into the materials, so we have a lower frequency. In the handbook, in the back, there is a section on material settings. Okay. So this machine, the Epilog Zing 16 30-watt machine. Okay. So this table is also for 40, 50 and 60 watt machines as well. So basically what we're looking at is these two columns here. If we look at the plywood that I've just done, for doing, there's some settings there for photo engraving, for clip art text settings. I use this setting here, so 400 dots per inch, okay, 50% speed and 100% power for doing the engraving. And then, and those will work on any plywood, irrespective of the thickness, because we're just processing on the surface. But if we want to cut through, now the thickness of the material becomes important. Yeah? So that was 3mm plywood. So using a frequency of 500, a speed of 70%, and a power of 60%. I actually found that didn't cut it all the way through, and I increased the power to 100, and that cut it through fine. You can tell on the edge of this, really, this sort of nice toasted golden brown. If it was excessive power, this would be black, charred, and it would actually leave like a sooty mark on your finger. Okay. But by going way too slow or way too much power, we could actually possibly put something on fire that way as well. Okay, so having these settings, having this chart as a starting point is good, but you might have to tweak these depending on, that piece of plywood I had might have been a 4mm or 3.5. I haven't got anything to measure it accurately. Okay, so these are a good starting point. You would definitely start here, start conservative, and then work your way up from there. So, sometimes you might send a job that might take half an hour to cut on here. The last thing you want is to get to the end of that half an hour job and find it hasn't cut it all the way through. Okay, so what you can do with a piece of waste material is just put some circles, just send some test circles to it, just so you can get your settings right. That's another aspect of cleaning the lenses and mirrors. If they are dirty, then it's not going to perform as well. Okay, so we're going to send the job to the machine. We need a piece of software that can actually generate raster and vector items. The one supplied with the machine is CorelDRAW. Just log into this. It's a piece of paper. So this has been set up by CSI, the suppliers. So they've actually configured everything. They've configured CorelDRAW, all the drivers, everything sorted. Just plug it in and go. Yeah? But they've actually created an account on the machine, so that's vital information. Cool. So this is CorelDRAW. What we want to do is get Inkscape as well. So CorelDRAW is you have to pay £400, £500 for a license or something like that. There is an open source equivalent to this called Inkscape, which is the preferred way of creating the files, obviously, because it's free. It means that somebody can create files at home or away from the laser and then come in and actually cut them out on the laser. So that's one thing that we'll need to sort out. But what we're looking at here then is vector lines. So just an example here. If I draw a rectangle. So if I draw a rectangle, we've obviously got an outline. If I click if I left click on any of these colours, it will actually fill that square with colour. Okay. If we try and zoom in on this, then we'll see that there's two things there really. There's the blue fill, okay, and there is a black outline here. So they're called the fill and the stroke. If I wanted to engrave over the whole area, then I could do that over the black colour. And I might want to cut around the outside. Okay, so let's go back to the keyring. So these are images. So this is a bitmap or whatever it was, PNG or TIFF or whatever that I've got off the internet. Okay. And those are pixels, they're coloured pixels, so it's going to see that as an image that it's going to raster over. So that's fairly straightforward. So we can either draw shapes and fill them, or we can get an image from somewhere else. Yeah? The lines are a bit trickier. So this is a vector line. So this is just the outline. Okay, so that would be it with a fill. That's it without the fill, just the line. Yeah? The laser won't see it as a line if it's too thick. So in CorelDRAW, it needs to be a hairline. If it's thicker than a hairline, instead of seeing it as a line, it will see it. It will see it as an area of colour that it needs to raster over. Okay, so it'll engrave it instead of cut it. Okay, but those lines are hairline. So if we want to send this job to the machine, then what I might do is if we copy this one. So if it's a good time to talk about the positioning actually. Let me zoom into the page. So that page represents the size of the machine. Yeah. If I go to layout, page setup, I can see that the size of the page is 406.4, which I think is 16 inches. Yeah? By 304.8, which I think is 12 inches. So that's basically the size of the machine. So there are two ways we can position things inside the machine, and that's to send the whole page through, or send just the job through. So it'll always use this top left-hand corner of the job though, and it'll position that as at the X and Y zero of the machine. The X and Y zero of the machine is always at this top left-hand corner, but we can temporarily move it to another location. Okay. That sounds confusing, but we'll have a look, and it's not too bad. Yeah. So if I've got this piece of wood then, basically those two fobs are cut out from that location on this piece of wood. So if I send them again, I know they're going to be in the wrong place. So if I select just that one though, if I pull it down to there, I know there's enough room there for that. I've got it selected. While I've got it selected, if I go to File and Print, to catch up. So you'll see in this section here that selection is enabled there, so it's only going to send what's been selected there, otherwise it would send the whole document. You need to make sure that the laser's the chosen printer, and then preferences. So this is the important bit here. So we've got two sections to this really. This is our engraving, raster engraving, and this is our vector cutting. Okay. So we might only want to send the raster, in which case we'd enable that selection, yeah? Or we might only want to send the vector, or we could do a combined job, which is what this is going to be. So we're going to do the engraving and the cutting. This is set at 400 dots per inch. We could actually refer back to this. Yeah, that's the one I used earlier, 400 dots per inch. Okay. That's going to dictate how many lines there are in vertically in the image. Okay. So the raster settings then, we've got a speed of 50, power of 100. Anybody know it? Speed 50, power 100. And there are different image dithering modes here. So that's how the laser deals with dots, because it's firing dots to create an image. So So you can use like the density of the dots to give you different greys, etc. Okay, so there's a good section in it in the manual. I'm just going to leave it on that for now. So this page size then has been set to the whole bed of the machine. You know, so you could set this to just the size of the job. Okay. It does have another manager where you can call up previous jobs, okay, or even send things to the manager so that you can queue up jobs for later. Okay. Or you can send it directly to the laser. So we're going to send it directly to the laser, but we'll leave this on as well. Okay, we'll come back to the centre engraving after. Okay, so I'm going to hit OK. I'm going to hit OK here then, and then I'm going to hit print. Okay. So we can see now on the screen it says job 1 key fobs. Yeah, I'm going to make sure the extraction's on. We've got the compressor on, we focused the beam on the material here. So now we just need to hit play. Hit play. So that's the rastering. So you can actually see it's going backwards and forwards, line by line, up the image. Yeah? So this is the cutting, because we're actually following the line now to cut all the way through. Okay, good. So as long as we can, you know, if there was smoke inside there, I wouldn't open the lid. I'd wait. I'd give the extractor a chance to clear the cabinet. Because if you open it too soon, you can let smoke out. And then, yeah, that's cut nicely all the way through it. So just quickly, if you've got enough battery, I'll quickly show you. If we do file, print, go back to preferences. This time I'm going to enable centre engraving, okay? And we'll say, let's say centre. So you can see the dots now tell you where on the job is going to be the new 0 point. So to move the XY0 inside the machine, and is always in that top left corner, yeah? Unless I press XY unlock here. Okay, I'm going to switch the red beam pointer on so I can see where the laser is going to be. And now I can pull this. And if I say that that's going to be the middle of my key fob, that lights it. What I can do now is, so we've got XY disabled, I've manually moved it. If I hit play, it's going to tell me that it's set the home to that position. Okay. So if I could, job number 2 key fobs in. And if I hit play, it's actually started from that point. Okay. So now, to make the best use of material, that's a really valuable thing to be able to do. And you can actually, if there's a good piece of material in the middle of a piece of scrap, then you can actually engrave in that position without having to actually trim all the bad bits away so you can get into the corner.
On, for instance, 0% power and get to trace out.
Yeah, you could do. Yeah, so that you can actually see where it's going to be. Yeah.
Just to make sure you don't put any other old cuts.
Yeah. Actually, so that might have been a bit misleading actually, because so you can, they're not. You can use these two independently of each other. Okay, so centre engraving will allow you to control where on the job the reference point is, okay? But you don't necessarily need it actually to be able to do this. So even with it off, what would happen now is that this would still remain the reference point in this corner, and that from wherever I put this in here would become the corner of the page. You know what I mean? So you don't necessarily have to use them in combination with each other. If you had something in the very top corner of there and you had a tiny little page, you could still put this anywhere on the piece of wood and get it to cut it out in that position. What else do we need to know? Some risk assessments, safe operating procedures, so we need to get up on the wall, yeah. Don't cut anything or engraven, no materials. Monitor the machine, don't leave it unattended. Preventive fire, position controls, isolation switching, tractor, lenses, focusing, software, speed, power, traction, door. Yeah.